Today is the 12th of October 2023, and would like to look at surface area of some shapes. Okay, thank you to everyone who has been watching our videos. Okay, if you haven't already, please subscribe, share, like and follow us. Okay, I will appreciate that a lot. Thank you. I normally write in the comment section, please follow my notes/script. Okay, if you are not watching, okay, and you are just listening, it will not help you. Okay, you want to watch and listen and see how I explain to you how you can solve a particular question. Okay, if you just want to use one method and you forget, then that is it, you can't do that. But if you understand the principles behind what you are doing, then it stays with you for at least for long or forever, even after you've done the exams. Okay, and then also, for instance, this is 36, this is 47. So if you hear 47, 36, go by this order. Okay, so that is why you need to be watching and listening, because if, for instance, I said 25 before 14, okay, or you heard 25 before 14, follow the notes. Now, scammers, okay, beware of them. Yes, is what I'll say. Okay, don't be chatting with people, so even linking with that. Okay, because I know that most of the people who are going to benefit from this platform may be taking their Gcse. Okay, they may be school age or young adults, or maybe a bit of older adults who want to go back into education. So beware, please. Okay, if the account is not yours, ask for permission to subscribe or follow or like, so that anytime I put up a video, you'll be notified. Okay, if you can open your own account, well, that would be good. But if you can't, then you're watching from somebody's platform, then ask for permission before you subscribe and share and like and follow. Okay, thank you very much. Now, recap. In our last lesson, we look at two quadratic equations. Okay, one on a graph. Okay, so we drew the table, got the coordinates, we plotted it on the graph. It was two quadratic equations. We found the point of intersection on the graph, and then we went on using algebra to also find the point of intersection. Okay, I said to you, normally they might just ask you to find the point of intersection on the graph, and that will be it. Or they might give you the two equations and ask you to find the values of x and y. Okay, so you are going to get two values of x. Put it back in one of these equations which you think is simpler, and find two values of y. Okay. If I wanted to give you another example, normally I would have given you another example in the recap, but if I want to do that, we wouldn't do what we want to do. So all I'll say to you is refer to the last video. Okay, go and watch the last video we just did. Okay, and help yourself. Okay, and if you have any question, example or question that you are solving, use that video to help you to solve your question, because it's the same method. Now today our starter, we've done some videos on sequence, and we did some videos on position to term rule. Okay, so this is just like a recap. Okay, so you can go back and look for that video, okay, and watch, okay, if you haven't done it before. And if you watch that, then it will help you understand this. Okay, but those who have watched it, this is just to brush our memory so that you don't forget in case you come into the exams. Okay, so our starter today, we want to consider the sequence 3, 14, 25, 36, 47. The 3 dot means that it continues to forever. Okay, so it's an infinite sequence. It does not terminate. Okay, a finite sequence, terminates, stops. So maybe after 47 you don't get any more. But if you see the 3 dots, it means it goes on and on and on. Now here, we want to find the position to term rule. We have a video on that, okay? And then use it to find the 67th term, the 201th term, and the 567th term, okay? If you look at the sequence, it's easy, but you can't look at it. 3 add 11 will give you 14, add 11 25, add 11 36, add 11 47. But we don't have time to be adding 11 till we get to the 67th term, and then go on to the 201 term, and then go on to the 567th term. Okay, so this is where the position to term rule comes in. Okay, now if you see here, if you look at the difference, it's a difference of adding 11. So add 11, add 11, add 11, add 11. Okay, so to add 11 from each term, okay, so the difference is add 11. If you add 11, you go to the next term. Okay, so for the first term, we have 11n. When n is equal to 1, the first term. Okay, now if you multiply 11 by 1, you have 11. Okay, now what do we do to 11 to get 3? Look at it. What would you add or subtract from 11 to get 3? Okay, you need to take away 8. Okay, so if you take away 8 from 11, you are going to get 3. So straight away, remember this is a starter, we have 11n minus 8. Okay, so what I did was I went back to test it. So if n equals 1, 11 times 1 minus 8 will be 3. That is the first term. If n equals 2, 11 times 2 minus 8 will give us 14. That will be the second term. If n equals 3, 11 times 3 minus 8 will give us the 25th term. So I've done it for n equals 4 and n equals 5, and I've got the 4th and the 5th term as we've been given in the sequence. Okay, so I've done this on the side. So it means our position to term rule here for this sequence is 11n minus 8. So I'm going to use that to find the 67th term, and then I've solved my first question. So n is 67. So 11 times 67 minus 8. If you do it on the calculator, you have 729. Okay, so that will be the first answer straight away. Okay, watch the video, it's very easy. Okay, now B, 201 term. So n equals 201. As long as you can find the position to term rule, you are good to go. So n equals 201. So 11 times 201 minus 8, which will give you 2,203. That will be the second one. Now, third one, n equals 567. So we are finding this term. Again, 11, 5 times 567 minus 8, which is 6,229. So instead of sitting down and adding 11, we found all this term in a short space of time just by finding the position to term rule, which is 11n minus 8. Okay, we have done videos on sequence and we've explained this. Okay, so go and watch the video, and then it will give you, if you've not done it, and then come and look at this starter. Okay, this starter is just a reminder if you are going to write an exam next year. The videos are such that if you take a video, there is a starter that is reminding you about something or something that you've done. Maybe you thought, because some of these questions can come, and you need to ask you to find the position to term rule, and ask you to find the nth term. Okay, and if you forget this, that is another mark lost. Okay, now today we are going to look at some diagrams, okay, and find the area of those diagrams. We started finding the area of some diagrams, like maybe we had rectangle or triangle or square, and then maybe we found the area of the shaded part and subtracted it from something. Okay, today we want to go a bit further, so look at it. So let's consider this diagram here. it is a square 1, 2, 3, 4, 5, 6. Okay, we have 6 squares all put together. Okay, now each side is 6.2 centimeters. So all I need to do is to find one square and then add multiply by 1, 2, 3, 4, 5, 6, and then I'll find the area of both. This diagram is not to scale. Okay, so with the square, each side is 6.2 centimeters. So if I find the area of one square and I add them together 6 times, then I found the area of the shape. Okay, so each side has 6.2 centimeters. So we'll find the area of the whole shape. So here, the area 6.2, so area of the square, okay, is length times length. So 6.2 centimeters times 6.2 centimeters, okay, on the calculator is 38.44 centimeters. Okay, assuming you are considering whether this is right, we've done a video on estimation. So 6 times 6 is 36. Okay, so assuming you put this in the calculator and it gave you this answer, well, because of the 0.2, it is right. Okay, just to make sure that you don't end up getting 384 centimeters squared. Okay, now remember your units. Okay, your diagram, the unit they gave you is in centimeters. Okay, so remember your unit. That's the diagram here. Okay, so remember your units. Okay, so your unit is in centimeters, so the area of one of the squares will be 36.44 centimeters squared. Now, but we have 6 of them, so the total shape area will be 6 times 38.44 centimeters. Okay, and then when you multiply 6 by this figure, you should get 230.6 centimeters squared. Okay, to 1 decimal place. Remember, area is the unit squared. So the unit they gave us is centimeters. So we are going to leave our answer in centimeters squared. Okay. Now, what have we done? Let's look at the shape again. That is a shape. If you look at it carefully, this looks like a cube. Okay, so if you wrap it, you fold it and wrap it, you are going to get a cube. Okay, so what we've just did, this shape, okay, we just found the surface area of a cube. A cube has 6 faces. So by finding one area and multiply by 6, we found the area of that shape. And if we fold them along these lines, okay, we've just found the area of a cube. Okay. Your ability to see this will help you a lot. So for instance, assuming I'm asked to find the surface area of a cube, okay, and I'm giving just this measurement, Okay, I should be able to split the figure in my mind and know that if I find one area of a square and multiply by 6, that will be the answer for the surface area. Okay, in case I've forgotten my formula, okay, but I hope you don't forget. Okay, so this is the first one. So what we just did, as I've explained to you, normally this is the formula we use, but we just found the area of a square, multiplied by 6, and then we got the surface area of a cube, which is this whole shape here. Okay. And assuming it's an open cube, okay, then this side will be there, but one will be gone. So you end up finding only the 5 of them, because the 6th one closes it. Okay. Now, let's look at our second shape. That is the second shape here. Okay. So we have 1, 2, 3, 4 rectangles, and we have 2 squares on the side. Again, not to scale. Okay. The unit is in millimeters. Okay, there. So don't leave your answer here in centimeters. Okay, so if you are finding the area of this shape, your answer should be millimeters squared, because you are finding the area. Now, so what I'm going to do, we have the length of the rectangle, which is this one, and we have the breadth 3.7. Okay, so let's find the area of the first one. So the area of one of them will be length times width. Okay, so this 10.8 millimeters times 3.7, because we know all these areas is 3.7. That all of them. Okay, not to scale, by eye judgment. They will tell us, so we can see it is 3.7. So the first rectangle, 10.8 millimeters times 3.7 millimeters. So we get 39.96. This is 2 decimal place. Okay. Now, if you look at the shape again, you have 1, 2, 3, 4 rectangles. Look at it. Okay. So the area we just found, okay, we are going to multiply by 4 to get the area of this side. Okay, this side here, this long strip here. So here we have 4 times 39.96 millimeters, which is 159.84 millimeter squared. Okay, remember, it's millimeter squared, is area, not millimeters. Okay, so that is our answer for the 4 rectangles. Now we have 2 squares on the side, so square 1, square 2. This from here to here is 3.7 millimeters, so this is 3.7 millimeters. That from here to here is also 3.7 millimeters. Okay, so 3.7 millimeters times 2 to find the area of the square, because the square has 4 equal sides. So if we multiply a 3.7 by 3.7, all in millimeters, we get 13.69 millimeters. Okay, so now we have 2 squares, okay, and 4 rectangles. So if we add them together, the 4 rectangles, we got 159.84 millimeters squared, and the 2 squares gave us 27.38 millimeters squared. Now when you add them together, you get 187.22 millimeters squared. So now you have 187.2 millimeters squared to 1 decimal place. Okay, now let's look at the shape that we've been given. If you fold them properly, okay, and use this to cover the side, that is this area, the surface area of a cuboid. Okay, look at it carefully, because if we fold these 4 rectangles, we'll use a square to cover one side and use the second square to cover the other side. We have a cuboid. So actually, what we've just found is the surface area of a cuboid. Okay, now a cuboid can be let's go back to the diagram. Okay, this has 4 rectangles and 2 squares, but you can also have a 4 rectangles, okay, and then you can have a 1 square there and the other one there. Okay, so you have to be careful what they are giving you. Okay, but this shape that we guessed it, if we fold them together, especially if you are good at puzzling stuff, you realize that if you fold them together, you are going to get a cuboid. Okay, and we just found the surface area, the area of all the shape, or the area of the faces. Okay, so that's what we guessed it here. Okay, so the 4 rectangles and the 2 squares. Now let's look at our last figure here. Okay, that is another shape. If you can see, we have 3 rectangles and 2 triangles on the side. Okay, so we are going to find the area again. So the rectangles, we know that from here to here is 14. So from there to there will be 14. Now the width is 3.9. Okay, and we've been told, okay, this here is 3.9, but that is the slanted height. Okay, we don't need that to find the area. Okay, this from here to here is 3.9. That'll be the base of the rectangle. The perpendicular height that we need to find the area of this rectangle is 2.5 centimeters, which we've been given. Again, the unit is in 2.5. So we are going to find the area of the three rectangles. Okay, so the area of one of the rectangles will be 14 times 3.9. So 14 centimeters times 3.9 centimeters. When you multiply them correctly, you should get 54.6 centimeters squared. Remember, it's an area. Okay, that is one of the rectangles. So if I want to find the area of these three rectangles, I multiply this figure by 3. So if I multiply 54.6 centimeters squared by 3, I have 163.8 centimeters squared to 1 decimal place. Okay. Now, look at the triangles. Okay. The base is 3.9 centimeters. I don't need the slanted height. I need the perpendicular height. Okay. Which is 2.5. We've been given that. So it's half the base times the height to find the area of this rectangle, but we have 2 of them. So to find the area of one is half 3.9 centimeters times the perpendicular height, okay, 2.5 centimeters. So we have 4.9 centimeters squared, again to 1 decimal place. But we have 2 of them. So 4.9 centimeters squared plus another 4.9 centimeters squared, which will give us 9.8 centimeters squared. Okay. So now the total area of this figure here is the area of the 3 rectangles that we found and the area of the 2 triangles on the side. If you do that properly, we have 163.8 centimeters squared, okay, plus 9.8 centimeters squared. Okay, now if you add them, you have 173.6 centimeters squared to 1 decimal place again. We've done decimal places, significant figures and stuff. So if you are not sure, go back and watch. Okay, go back and help yourself. The videos are there, all of them. Now look at this carefully. Okay, if you put them together, this looks like a triangular prism. Yeah. So what we just did now is to find the surface area. So if I fold this rectangle into a triangle and use these 2 triangles to cover both sides, I have basically found the faces, the surface area of a triangular prism. Okay, so that is what we just did. Okay, so what did I want to say to you today? Okay, you can find the surface area of a shape just by opening it up in your mind. Okay, they might give you a shape like a cuboid. Okay, because at times you might have the formula and you might be thinking which is which. Okay, but there are times too they might not give you the prism for it to have equal rectangles. Okay, so you might have to find each rectangle area of each rectangle, and then find the area of the triangle. Because if one part of the rectangle is higher than the other part, then it's not going to be an even one. Okay, so I think tomorrow I'll look for more of these shapes. Okay, but all I wanted to show you today is some of the work around surface area are shapes that you can split. Okay, so for instance, looking at this shape, your ability to see it that if I fold them together, okay, and I'll get a rectangular prism can help me. I'm talking about this word, prism. Okay, can help you break it down to solve it, even though you might not know the formula. Okay, so tomorrow I'll bring you some standard formulas that can help you, and we'll look at some more challenging questions to see how we get on. Okay, but maybe tomorrow I might not split the figure open for you this way. Okay, we'll just bring it and then I'll explain and show you, so that in an exam, if you see it and you can't split it, you will know how to solve it. Okay, so this is what I wanted to show you today. Okay, so even though we found area of different shapes that have been opened up, actually what I wanted to show you is introduce you to surface area and how some of these surface areas are being solved. Okay, so if maybe you can't even see to get your formula straight from the figure, you can split it open in your mind and solve it shape by shape and still get the answer right. Okay, thank you very much for watching today's video, and I'll see you in the next.